Welcome back to Chemistry with Mrs. Miller at BVISD. We're taking a look at Chapter 12, the chemical quantities. So, just a reminder, you're going to want to do a couple concept checks about the types of compounds, naming compounds and writing chemical formulas, writing and balancing equations, and the factor label method, which is also known as dimensional analysis, and the behavior and laws of gases. So just take a quick moment, make sure that you sort of have a review of everything going on, and you will be ready to proceed. So 12.1 is counting particles of matter. So what we want to be able to do is compare and contrast the mole as a number and mole as a mass. Now, relating and counting particles to weighing samples of substances and be able to solve stoichiometric problems using molar mass. Now, the vocabulary that we're going to be looking at is stoichiometry, which is simply the study of the relationships between measurable quantities like mass and volume and the number of atoms in a chemical reaction, which aren't measurable, or they're measurable but not countable. So, and then we have the mole, which is a unit of measurement used to count numbers of atoms. Molecules are formula units, sort of similar to a dozen. Now, we also have Avogadro's constant, which is 6.02 times 10 to the 23rd. Molar mass, which is the mass of 1 mole of a substance. So basically this is relating to the mass on the periodic table. So iron is 55.847 and plutonium is 195.08. So we also have molecular mass. Now this is the mass in atomic mass units of 1 molecule. One molecule. Now this is a mass in grams of 1 molecule of a covalent compound. Alright, now we use formula mass for ionic compounds, and this is mass in an atomic mass unit in 1 formula unit. A little bit confusing, but we're going to break it down piece by piece. So stoichiometry. The whole point of stoichiometry is that atoms are too small for us to actually see, let alone physically count. And that becomes hard to wrap our brain around because there's so many in such a small space. Avogadro began to bring this together in his Avogadro's principle that we learned about in the gas laws. And he was able to relate volume to the number of atoms. And basically, if you don't remember what he said, is that at a constant temperature and a constant pressure, a volume of a gas, whether it be helium or neon, had the same number of atoms. Now, stoichiometry is used to measure the amounts of that substance involved in a chemical reaction. So, let's look at a practical example. This is going to be a listening check that you need to put into your journal. Now, this is a practical example, obviously, because we have a 55-gallon drum, and I'm going to fill it with pennies. But I want to know how many pennies are in there. So I know the mass of all the pennies that I put in there is 70,125 grams. Now, the mass of 1,000 pennies is 2890.7 grams. So we could, to find out the total number of pennies, count every single one. I personally would lose count. So not a good plan for me. And I don't have that much time. But we can calculate the amount of pennies using the information we already have. And if it's me, I'm going to take the calculation one. So what I want you to do is put in your listening check journal, I want you to work this one out. Now, it's completely impossible and incomprehensible to be able to understand the amount of grains of sand in the desert. So we're not going to be able to count the number of atoms in a drop of water either. Avogadro developed that idea, and so he put it that the idea of a group or unit of measurement used to count the number of atoms, and he called that a mole, M-O-L-E. It's abbreviated M-O-L. So that mole stands for 6.02 times 10 to the 23rd, and that's Avogadro's constant. A mole is basically like saying a dozen meaning 12, a mole meaning 6.02 times 10 to the 23rd. Now, molar mass. The point of this section is to understand how molar mass relates to other things. So, in an example, let's look at how many moles of methanol are there in 500 grams of methanol. Well, the equation for this is CO2 plus 3H2O yields CH3OH, which is the methanol, plus water. Now, the equation relates molecules, but we're looking for mass. And so we have reactants and products, but we need to relate the macroscopic measurement, the mass of CO2, to the number of molecules of methanol. Now, to do this, we need to know how many molecules are in methanol. So let's take a look and break it down. We can use the moles to help us with this, but we must know the mass of 1 mole of methanol molecules. So that's the elemental molar mass, which is equal to the average atomic mass. So we get that from the periodic table. Now, an example of this is like carbon is 12, and 1 mole of carbon has 12 grams. So what is the molar mass of pure hydrogen? Hydrogen being 1. Well, it's 1 gram. So let's look at what is the molar mass of an oxygen molecule. Well, that's O2. So basically, oxygen's atomic mass is 16, so we have to do 16 times 2, which gives us 32 grams. So let's look at a problem. The mass of an iron bar is 16.8 grams. How many iron atoms are in this sample? Well, first question we need to ask ourselves is, what is the molar mass of iron? Well, it's 55.8. So if we convert the mass of the iron bar to the number of moles of iron, and then use the mass of 1 mole of iron atoms as a conversion factor. So let's break that down. 1 mole of iron, right here, is equal to 55.8 grams of iron. Well, we already have 16.8 grams of iron here, and we need to get rid of that. So now we have that 16.8 grams of iron, that conversion factor between moles and iron, and now we have a conversion factor between moles and number of atoms. So we actually needed 2 conversion factors to get to where we're going. So we can simplify that. So 16.8 grams of iron times 1 mole over 55.8 grams of iron times 6.02 times 10 to the 23rd over 1 mole. So we can simplify the grams and the moles, leaving us with the equation 16.8 times 1 times 6.02 times 10 to the 23rd, all over 55.8 times 1. Well, that's just math now, and it becomes 1.81 times 10 to the 23rd iron atoms. So we start with grams, we have a conversion factor from grams to moles, and then we have a conversion factor from moles to numbers. So, another example. Molar mass of a covalent compound is the mass in 1 AMU of a molecule. So when we have a molecule, we have to add those masses all together. So let's look at ethanol, whose chemical formula is C2H6O2. So we have 2 carbon atoms, we have 6 hydrogen atoms, and 1 oxygen atom. Carbon, it has an atomic mass of 12, so we're doing 12 times 2, equaling 24. Hydrogen has an atomic mass of 1, but we have 6 of them, so we're multiplying it by 6. And oxygen, there's only 1, but it has an atomic mass of 16. So we add the 24, the 6, and the 16 together, and that's going to give us the molecular mass of ethanol, which is 46. Well, we need the mass of 1 mole of ethanol, of 1 ethanol molecule, and we get 46.0 grams. Molar mass of ethanol? 46.0 grams per mole. So that's the end of that. So it's pretty easy. You just break it down. You're going to have to add it up. There might be a few steps when you have some problems. But remember, break it down step by step and you will be fine. So formula mass. And this is used for ionic compounds. So sort of the same way as the molecular mass. So here we have calcium chloride, CaCl2. 1 atom of calcium, 2 atoms of chlorine. Calcium is 40.1 U's, but there's only 1 of them. Chlorine has 35.5, and we have 2 of them. So we end up with 71. So 40.1, 71.0 equals the formula mass, equaling 111.1. So the mass of 1 mole is 111.1 grams. Formula mass of calcium chloride, 111.1 grams per mole. Easy peasy. So here's some more of your listening checks. You need to determine the number of atoms in the sample group. So 98.3 grams per hydrogen, Don't forget to go look at your periodic table. 144.6 in tungsten. Now we want to determine the moles of each sample. 16.0 grams sulfur dioxide, 17.5 grams of copper-2 dioxide or oxide. Please remember, here we're looking for the number of moles, number of atoms. So the way we express them, this is like saying we have 6, and here we're saying we have half a dozen. Okay, determine the mass of the following molar quantities. 33.52 moles, and we're going to go to the mass, grams of silicon. 1.25 moles of aspirin. Remember, we're going to mass to grams. All right, for further listening checks, without calculation, decide whether 50 grams of sulfur or 50 grams of tin represents the greatest number. All I need you to do is write down the correct answer. Don't forget the question. Sorry about that. Okay, so how is counting a truckload of pennies like counting the numbers, counting the atoms in 10 grams of aluminum? The average atomic mass of nitrogen is 14 times greater than the average of hydrogen. Would you expect the molar mass of N2 to be 14 times greater than that of H2? Why is the following statement meaningless? An industrial process requires 2.15 moles of a sugar-salt mixture. Okay, take a break, finish your listening checks, and we'll see you next time.